Maybe make it back. We have one more section I definitely wanted to finish out today, and then we'll see a little bit into the last section of 8. The more we finish today, that means the more we can just review tomorrow. Right? Tomorrow's going to be review. Just make sure you guys all realize this. The test is Wednesday, right? You knew that from day 1. Cool. Or even before day 1, to be honest. So any questions from the last section we just did, the compound inequality stuff? I mean, we don't do anything too much more than what we did. Just got to remember what the difference is between and or. I'm trying to figure out if I want to do... Yeah, we should. Yeah, let's do this. Okay. A4 kind of goes beyond just linear functions. We start looking at other functions in general. By this point, you really should know, especially in this class, what a line looks like, what an x squared looks like. It looks roughly like this. Does anybody know what an absolute value looks like if you graph it? It looks like an absolute value, of course, looks like this, but if you graph an absolute value equation, what would it look like? Yeah. So V. Okay, so we'll look at that. Let's start with this, though. So 8.4 is all about other functions. So functions like, f of x equals 8x squared minus 4, square root of 7 minus 2x, stuff like that. Let's say h of x equals 1 over x plus 2. Right. Let's look at these 3 examples to start off with. So we have a polynomial function, specifically secondary quadratic. Right. Then we have a square root function. And then we have good old rational expression that we just came out of, a rational function. We're going to figure out graphically what that thing does, because you should know. Let's start with h. What's the domain of this?
Everything except -2.
Yeah, good. So x can't be -2. Now let's see if you guys take a minute and see if you can write that in interval notation. You guys can merge something I said earlier. This is almost everything, right? Right? This is just missing one thing. So in terms of all the numbers, it's almost missing nothing. It's one thing out of an infinite number of things. But it's almost negative infinity to infinity, but it ain't, right? It skips. And that's what I think of as skip. What specifically do I want to skip here? For something very specific. I want to skip -2. Bam. From negative infinity to stop at -2, restart on the other side of -2 up to infinity. So you've just skipped over -2. Let that sink in. Okay. I like it. All right. I don't know if they ask you. That would be a little bit evil. That might be a little too early. I'm not going to ask you that question yet. Okay, I'm not going to ask that question. Let's look at, we might as well just go to g of x. So tell me, real quick, how did you guys arrive at this truth? That's the domain. Everything except -2. How did you get there?
Because it'll make the denominator.
I love it. So the function is in the form that if the bottom is 0, it's got a problem. I love it. What's this in the form of? If this happens, it's got a problem.
It's negative.
Yeah, if the inside is negative, it's got a problem. So, and that's a lot of things, right? So it might be easier to say, okay, when is it okay? So it's the opposite. If the inside's negative, it's got a problem because it becomes complex. It becomes not real. So when is it okay then? Whenever it's not negative. Well, what's not negative mean? So when the inside is not negative, that's going to be the domain.
Is that the same as all real numbers? No.
No. Because there are x's that make the inside negative. What if x is 8? Doesn't this become negative inside? 7 minus 16? Is that cool? You guys see that? No? All right. If x is 8, that's all I'm saying right now. Why? How could I say that? Because I'm just investigating what x can be. So let me throw something in there. If x is 8, what happens in here? 7 minus twice 8, 7 minus 16 is negative 9. Can you do the square root of negative 9? Hell no. Not without using complex numbers.
I got called into work. I gotta go.
Shit. Okay. See you tomorrow. Where am I? Oh, yeah. All right. So did what I just do, is that something you have to always do? No. I'm just getting a feel for this. I'm just showing you why I know there's at least one thing I can't use. 8. But then if I can't use 8, I can't use anything 9, 10, 11. It's going to make this more and more negative. It's going to make the inside more and more negative. So there's got to be that dividing, that number on one side it makes the inside negative. On the other side it makes it not negative. All right. So that's the idea here. The beautiful thing is, for square roots, you always do the same thing. You say, when is the inside not negative? Now, what does not negative mean mathematically? How can that represent with a math symbol? What does not negative mean? It means it's at least greater than not negative. Tell me some numbers that are not negative. 4, 1800, 0.7. They all have to be bigger than 0. That's the basic definition of positive. But what else is not negative? 0 itself, right? So what's negative numbers mean? Less than 0. Is that cool? That's another way to say negative number. A number is less than 0. So what's not negative? The opposite of less than 0, greater than or equal to 0. So I want the inside to be greater than or equal to 0. So whenever you see a square root function, you can just write this and then replace it with the math. What's the inside? 7 minus 2x. Whatever this number is, 7 minus 2x is a number. I have to have it be at least 0 for this to be doable. You guys with me? And you can do this all the time. What's here? Say it in words. What must happen? X plus 2 must not be 0. When you solve it, what do you get? This. So if you can say it in English, write it in Mathish, solve it. That's how you do any domain of any function they give you. Say it in English, what has to happen? Write it in Mathish, and then solve it. English, inside's got to be not negative. Mathish, 7 minus 2x greater or equal to 0. Solve it. Now, that should be quick, right? How do you solve this? Yeah, you could add 2x, divide by 2. So x will be on that side. Now x is less than or equal to 7 halves, which matches up with like 8 not working, because that is more than 7 halves, right? So what happens when I plug a 7 halves in? Twice 7 halves is 7. 7 minus 7 is 0. That's fine. That's the biggest it could be. All right, let me stop there for a second. How's that? Is that decent? Okay. So should 3 work? Yes, because this is 3.5. 3 is less than that. 3 times 2 is 6, and 7 minus 6 is 1. Yeah, it works. Okay, cool. All right. So how would you find, if I gave you this function? I've already got f, g, and h. So I'm going to use k of x equals square root of 5x minus 11. What's the domain of that one? Don't say anything out loud. Just take a minute, figure out the domain. right? So what do you write? So I know that the inside has to be at least 0. So 5x minus 11 equal to 0. Add 11, divide by 5. So x has to be at least 11/5 for this to come out to be a nice number, for this to work, right? Using real numbers.
And that's the domain, right?
That's the domain.
Okay.
Exactly. I love it. Just like if I had, 1 over x plus 2, in English, what can't happen? The bottom can't be 0. When I solve it, that is the domain. So if you say in English what must be true, write it in Mathish and solve it, it's almost too easy to believe. Some of you guys like, I still don't understand this shit, but you got to make some sense on some level. It's all you got to do. Now watch. You ready? Here's where things get a little wonky. What if I had L of x equals the 5th root of 4x plus 2? Now, just to let you guys know on this, there should be no work to do. No work is required on this. None. 0 work. Why does this have a problem? Because it's a freaking square root. Square roots can't handle negatives. Why? Because any number times itself comes out positive. Any real number. Let me be very careful. Any real number times itself comes out positive. If I have 3 numbers, what's 2 times 2 times 2? 8. What's negative 2 times negative 2 times negative 2? Negative 8. So an odd number of things retains its sign. An even number of things, when you multiply, will always come out to be positive. Right? Even number of same numbers. Okay. So somebody will look at me like, wait a minute. Odd roots, then, can handle negatives and positives. What's the cube root of negative 27? Negative 3. We were doing that when we were doing cubes. Right? Difference of cubes. You guys semi with me here? Odd roots have no problem. So when you try to say in English what the problem is, there is no problem, right? So what's the domain of this? All real numbers. If it was a 4th root, I'd do that work. Because an even root cannot handle negative numbers. Now really take that in. Really think about that. If you multiply a number by itself 4 times, it will always come out to be positive. A real number will always come out to be positive. That's related to why even numbered roots have issues and odd number roots don't. Yes?
Is it kind of like how when we factor stuff, like we can't do x squared plus 4?
Beautiful.
We can't do that.
Exactly. I love it. Yes.
And
Yeah.
then, like, if that was a 4, if it was a 4 root, like, you would still solve it.
I would do exactly the same
Because you
work.
don't wanna get
In fact,
negative.
this domain is true for any even number. 12th root has that domain. Even root, the inside has to be at least 0. So that the domain work wouldn't change at all. It's just because it's an even root, I got to do that. If it's an odd root, I got to do anything. Unless the inside has a problem. Does the inside have a problem? What do I mean by that? So this one would be all real numbers. Or if you like interval notation, then infinity to infinity. Right? So what if I had this one? M of x equals the 7th root, so no problem yet, of 2 over x squared minus 9.
X equals root.
See, that's a little bit even. But you look for a problem anywhere. Is there a problem with the root? No. The root can handle positive, negative, 0. It can handle everything. Can the inside handle everything? No. You probably don't have to do any work. What 2 numbers can it not handle? 3 and negative 3. So your domain would be x not equal to 3 and negative 3. Or, if you like, or if I ask you to do interval notation, start at negative infinity. Where's the first problem I hit?
3.
Negative 3. Start over again, negative 3, up to 3. Start over again from 3 up to infinity. So I skip negative 3 and I skip 3. I just like thinking of me as skip. Right? People make a mistake and they do negative 3 to infinity, but then you left out everything in between negative 3 and 3. What happened to those poor dudes, Charlie? What is it? So there'll be a little section in the homework all about finding the domain given a function like one of these. Okay. Let's look at absolute value like I was talking about earlier. Oh, by the way, this last guy. Well, let's see. There's one little thing I want to talk about with this last guy. What's the domain of f? What's the issue? Does f have any issues anywhere? Does it have anything in the bottom? Does it have anything inside of a root? Does it have any issues? No. In fact, what is this a form of? This is a polynomial. Polynomials, the reason we give them that word is because they work everywhere. They're okay with any x. Is there any number I can't square? I can square every number just by writing it twice and then doing it multiply. Right? Are you guys with me? And then is there any number I can't multiply by 8? No. And anywhere I can't subtract 4? No. So it's got no issue. So what's the domain? All real numbers. There's no problem points anywhere. Right? Here, there's a problem point. Bottom can't be 0, so there might be some x values that make that happen. I got to keep here. Inside can't be negative. Okay, shit. I got to throw out the x values that would make that happen. Shit. Here, everybody's on the top. Nobody's underneath anything. Fantastic. Right? No problem. Now here's the more interesting question. For this guy especially. What's the range for this guy? And what's range reference? The y, the outputs is a better way to look, the more general way to look at it. So really, which direction is this parabola facing? This is why it wouldn't be. It's not down. It's sort of. This is not a line. True.
True.
But there's a connection here with the idea of slope. If this is a positive number in front of the x squared, it's going to be up. If it's a negative, it's going to be down. Right? So it's not slope exactly, but it is related to slope. If you get to calculus, you'll start to see the relationship to slope. So in general, if this would have been negative 8x squared, it'd be down. This is positive 8. So it goes up, which means, is there any ceiling to this? No. So all I got to do is find the floor. There's definitely a floor, right? It goes down, and it's got the lowest point, and then it goes up, right? So like we're Earth here, and then we got this comet coming around us, whee! And I just want to see, okay, where's this? This is, let's make sure that this isn't here. So bam, boom, we got to send, people up there and whatever. Sorry, went off on a big tangent. So what the shit? I got to figure out what's the lowest point this is. Well, what's the lowest point for that? What's the smallest 8 times x squared could be? What's the smallest x squared can be? 0. Let that sink in. Is that cool? 0 squared is the smallest, right? Negative 1 squared is 1. 1 squared is 1. Shit, so 0 is the smallest. 8x squared, the smallest it can be is 0. So what's the smallest this whole thing can be? 0 minus 4, negative 4. So what's the range of this then? It goes from negative 4, and of course we just said that there is no ceiling, so it goes all the way up to infinity. I like it. So there are objects, just so you know that there's the sun. And there are, like Halley's Comet, for example. It's got this elliptical orbit around the sun. So it comes back every 76 years, I think. Mark Twain, of course, was born when it came and died when it came again. So it's like, Halley's Comet created him and then destroyed him. So I don't know. But there are actually objects that have this parabolic motion. They'll just come by once. They'll come by once and then they're gone. We never see them again. As far as we know, that's infinite, right? They just go to infinity. If they get sucked in by some more gravity, maybe we'll do something freaky. But as far as we know here, it's just infinite. I hope I'm not freaking you. You guys should know a little bit about planets, orbits, and they're almost circular sometimes, and some of them are a lot more elliptical. And you have any body has some kind of weird kind of shape to it. Okay, the orbit it takes. So there's the real life application of some of this. Okay, so that's the range for that guy. Let's look at absolute value, because absolute value is going to be behind the whole next section. So let's really analyze the hell out of absolute value. Let me start you off with a question that you will answer wrong. It's really, really, really easy to answer this wrong. But first off, before I ask you that question, before I ask you the question that's easy to get wrong, let me give you one that should be easy to get right. What's the absolute value of negative 3?
3.
Good. Why?
Zero.
Say again? I love it. So absolute value always comes up positive because it's based on distance. Even if I turn around, you're not like negative 5 feet away from me. I mean, you're inside me, right? Quaid. No. Quaid? No. Quaid? No. Okay. Total recall. No. What's the absolute value of 5 then? 5. So absolute value is the most single-minded function there is. It just always makes it positive. So when does it actually do something? Did it do anything here? Think about it. Did it do something to 5? No. Did it do something here? Yes. Okay. Trying to help you for this question. So what is the absolute value of x? See, that's the wrong answer. Now think about it. See, that's the answer you get when you don't think. Now think. What is x? What could x be? Didn't we just say that sometimes it doesn't do shit and sometimes it does? How do I know? When will it not do anything? If the number inside is already, if it's already positive, it ain't gonna do shit. But if the number inside is negative, it'll do something, right? So there are two different things it does: something or nothing. Okay. You're gonna love this. Now, so what is x? So if you say the absolute value of x is x, somehow you're telling me you already know x is a positive number. How do you know that? That's some neat shit right there. Right? That x you just drew, that's a positive number. I don't know. Shit. Right? So okay. Here's the freaky answer. And this is why, personally, I wish they would have never actually come up with this notation. Now, it's really weird for you guys to hear a math person say that. But this is one of the few notations that hides what it does. I'm going to show you what it does now. Full blown, here's what it does. So when will it be just x? If that number is positive or 0, right? What's the absolute value of 0? 0. So it doesn't change if it's 0. X if x is greater than or equal to 0. Now what if x is less than 0? What does it do? So what does it actually do here? Change the sign. How do I change the sign of something? Multiply it by negative 1. So the absolute value of x is negative x if x is less than 0. And here's where people go, no, Jeff, no. Jeff, you should not teach math because absolute value has got to be positive. Well, this is freaking positive, isn't it? It's a negative times a negative number. So that is positive, isn't it? So let's check it. So here, that should be negative. What that is, negative 3 is 3. So that is mathematically how you change the sign of something, is you multiply it by negative. Now, right now there's somebody out there going, why is he making absolute value so hard? Why do teachers do this? Oh my God. Matt, I knew absolute value. I know it. And what the hell is he doing? Well, I'm showing you the full idea of absolute value. Absolute values are easy if that is a number that I can tell what it is. If I know what the value of the number is, easy. Right? Do I always know the value of the number? Hell no. So I have to know what happens if I don't know the value of the number. Okay. All right. Yes?
So they're not going to tell you, like they're not going to put a negative in front of the x, like in the beginning.
Yeah, so here's the idea. Eventually we're going to get here. If I had this equation, there will be two answers to cover the ass of it not knowing what x was. There will be two answers. Either x could be, the absolute value of what is 5? 5 or negative 5. So this is really what this means. There will be two answers to this. If I have an absolute value equation, there are inherently going to most likely be two answers. Because of this duality, because of what it can do two different things based on what number it actually is. You guys are all like, what's wrong with this guy? Come on. Okay, all right. So. That's going to lead into the next section. Just keep that in mind. That's really what absolute value does. And this is why I don't like it, because it actually does two different things, and this makes it look like it does one thing. Okay. So taking it back a step. Can you guys graph this? And I'll give you a little help. There. So once we graph this, I want you to tell me why I picked the numbers I did. Of course, when you put a 1 in there, you get absolute value of 1 minus 3, absolute value of negative 2, which is 2. Absolute value of 2 minus 3 is 1. Okay? Because you get the absolute value of negative 1, which of course is 1. 3 minus 3 is 0, absolute value of 0 is 0. And 4 minus 3 is 1. Absolute value of 1 is still 1. So really, you see why I chose 3, because this really, what does it say? It's the distance between a number and 3. So 4 is 1 away from 3, but so is 2. Right? 5 is 2 away from 3, but so is 1. So that's why it takes this shape. And why is a parabola curved? Because it's got a second power. It's not linear. Doesn't this want to be linear? Because it's got a first power, right? So on this side, so just to finish it out, 5 minus 3 is 2, absolute value 2 is 2. Is that cool? So at 5, 2, 4, 1, 3, 0. So it's going great. It's like, yay! And then it goes, oh shit, I can't go negative. So then it just, bam, right? 2, 1, and 1, 2. So it's linear. I really should go through 3, but you guys see what I'm saying? So it's trying to be linear, but then it's not allowed to go negative. So it's got to go, oh shit, right? That's a plane you do not want to be on. You're all dead. Can't make the turn. So parabola turns for the same kind of reason in a way. You can't square a real number and have it come out negative. So parabola would kind of turn, but it does so in a nice, gentle way because it's squared. It's allowed to curve. This ain't allowed to curve. It's a first power. That's why it makes a V, not a U. Okay, maybe. I love the looks like this sometimes. Do you guys understand? Why does a parabola turn? Because it's not allowed to go negative. Okay. It could be negative on like x squared minus 3. I can make it go, but it still turns at some point. It can't go below negative 3, for example. It's got to turn somewhere. Absolute value. It's got to turn for the same reason, but it does it in a linear way because it's to the first power. It's got to be a line. It's got to be a straight line. Okay, maybe. All right. Okay, cool. Oh, now let's focus for a minute on, like I said earlier, the rational function and what it looks like on a graph. So that one we had earlier was 1 over x minus 2, was it something like that? Plus, okay. We'll do the same. All right. So what number can I not use here? I can't use -2, right? So let's do this, and then we'll make this more general. I want you to get the idea of this, especially if you're going into calculus. This is what we're about to talk about right now is going to rule your life, especially for the first month of calculus. And you're all like, all right, let's see what this shit looks like. Well, let me see if this makes sense. Anybody, let me see if I can show you this. Anybody ever seen the movie The Blob, especially the 80s one? You ever heard of the movie The Blob? I'm a big horror fan, so. All right, some dude sees this thing fall from the sky, this meteorite. He comes up close to it, and it's like this little jello-looking thing kind of moving around. Now, any rational person would get maybe this close and go, let me call somebody. That thing's moving around. So this guy doesn't, he just goes all the way and touches it and it just goes, wraps around his arm and eats him and all that kind of shit. Horrible, right? We cannot get at -2, but I want to get really close and just see. I can't touch it because I'm not allowed to put a -2 in there, but I want to get really close and see what the hell happens, right? Like, what is that thing? It moved. Okay, I saw what happened. I'm going to go this way. Oh, yes, maybe. You're like, what the hell does math got to do with jet? I don't care. Right. So I'm going to do this. I can't put -2 in, but I'm going to get as close as I can. So let me put -2 here. I can't use it. Let me put that in parentheses. I can't use it. Let me put it even here just to make it even more in your face. H of x. Okay. So maybe I'm going to go like, from above it, I'm going to go -1.5, -1.9. And then from the other side, I can do like -2.1, -2.5. Maybe we'll even get a little bit closer. Let's see. In fact, let me try to squeeze in here. -1.99, -2.01. All right, so somebody help me out. Let me see if you guys can all use your calculator correctly, or if you even brought one. 1 over -1.5 plus 2. You should be able to do this without a calculator. -1.5 plus 2 is 0.5. 1 divided by half is 1 times 2. You get 2. So what about -1.9? It'd be 1 over -1.9 plus 2 is 1 over 0.1. What is 0.1 as a fraction? 1/10. 1 divided by 1/10 is 1 times 10. It's 10. All right. Are you guys doing okay? I'm just plugging numbers in. If you can use your calculator correctly. And what do I mean by that? If you want to do this one, you don't say 1 divided by -1.5 plus 2. Why is that not good? To put that in your calculator. Why is that not good? You're only dividing by -1.5. You're supposed to divide by -1.5 plus 2. Poor calculator ain't got no eyes. I can see, because I got eyes, I can see that's all on the bottom. I have to put parentheses around, so calculators, oh, that whole thing is on the bottom. I see. Yes, I don't want the model that's got the eyes. It's freaky. All right? Calculator, look at this problem. I don't know. This is it. It's a little freaky. All right. And then -1.99, you guys see how that would be 1 over 0.01? 100th, so that's going to be 100. All the same shit happens on this side, doesn't it? Except it's going to be negative. What's -2.5 plus 2? -0.5. So it'll come out to be -2. You guys, if you don't believe me, you can plug these in yourself. So this will be -2. This will be -10. This will be -100. So on this side, so here's -2. From above, do you see what I mean by from above? As I approach it from this way. So at -1.5, right here, the output is 2. And -1.9, the output is 10. So -1.9, like right there. And -1.99, the output is 100. -1.999, the output, of course, is going to be 1,000 because I see the pattern now. So the closer I try to get, the steeper it gets. Right? I always think about that sign. It's a trap. Pull up. No? Star Wars? No? General Akbar? It's a trap. No. Okay. Admiral? Thank you. I demoted him because I thought I had that. So here it's going like this. We can put some more stuff. It's going like this. Whee! I'm not allowed to be at 2 though. At -2. So you guys might realize what the closer I try to get to an input at -2, and I can't go right at, the steeper this gets. -1.999999999 is going to be like billions, right? Wow. Okay, I don't know if anybody's ever seen this kind of thing before. Anybody know what this kind of behavior is called? This is an asymptote. I love it. This is an asymptote. Something you can get really close to, but you never get to it. So I can get as close as you want me to this line, this dotted line, but I can never hit it. So what happens on the other side, the same thing, except it's going to be going down. So it's going to be, wow. Maybe. Stop there for a second. So if it would have been, you see, 1 over x plus 2, it's going to have a dotted line at -2. What if it was 1 over x minus 5? It's going to have a dotted line at 5. I love it, right? Because it can't be at 5. So you got to put a wall, this dotted line wall at 5, and then slam into it. Okay. So what happens out here? Well, what's the only way to make a fraction equal 0 is if the top is 0. The top of this fraction is always 1. So I can make the bottom become as big as I want it to be. I can make the bottom huge by making x crazy big, right? All right, let's try. So what if I make x 10? This is 1/12. All right, so at 10, it's at 1/12. Woo! At 100, it's 1 over 102. You guys see what's happening? At 1 billion, it's 1 over 1,000,000,002. Is that 0? Is 1 divided by 1,000,000,002 0? No. Is it really close to 0? Hell yes. 1/1000,000th is really small. Are you guys? So this, again, holy shit, this is another freaking asymptote. So this is kind of mirror image back here. Whee! Why does this look so weird? Because our variable is on the bottom. Shit, I should have expected to have some weirdness. There's a place it can't even exist. It's going to have to make the whole thing go crazy. Okay, so the bottom cannot include a value of -2. So there's a wall there. And there's no way this thing can equal 0. So there's a wall there. An asymptote there. Okay, let me let that. And this is really just a little preview. I mean, it's not gonna get any deeper than this. So if I gave you a function 3 over x plus 4, where's there going to be a dotted line? At -4. And again, it can't equal 0, right? So it's basically going to look like this. Wow, just to do a real quick one. And you can plug some points in to get it more specific like we did that one. But I already know where the wall is going to be. I already know where this wall is going to be. Just because I know what value of x can't be used, so I put a wall there. Let that make sense. Can't use this shit. And I already know the output can't be 0, so I put a wall there. Now, is there more to this? You should be able to expect yes, because I could put more shit on top, more shit on the bottom. But it basically builds off of what we just talked about. If I put more stuff on the bottom, there's going to be more up and down walls. So if I put this on the bottom also, there'll be a wall at 1, right? And then you got to start talking about, well, how does it come up? Does it go up to the wall? Does it go down the wall? I mean, that's going to be pre-calculus is where you really get into that. Here I'm just starting to lay the groundwork of what an asymptote means. It just means this. You get really close to something and it just goes out of control. That's where it just goes, okay, oh shit, right? That's an asymptote, is that, oh shit, Yes.
Why is there a wall on the X?
Oh, here.
Yeah.
Because the output of this, so the input cannot be -4. So that's why there's a wall here, right? And the output of this, it can't be 0 because, is that cool? Now I can make this, so 3 over x plus 4. I can make this any number I want to. How do I make it equal to 1? Well, I can multiply it up, solve for x. Do you guys see what I'm saying? Any number you put here, I can solve for x and make it happen. I really want you to understand this. I get every other output there is. But the minute I put 0 here, and I try to multiply this up, what happens to the x? It dies. Can I solve for x then? It's the only number that I can't solve for x. So that's the only number that I'm not allowed to have as an output. Okay, maybe. Okay, so it doesn't get much beyond that. I even maybe went a little further than the book does right now, but don't get too freaked out. It's not going to get more than that for right now. Let's see, blah, blah, blah. Blah, blah, blah. Oh, so the last thing in this section A4. Let me just get your take on the last thing in the section A4 compared to what we just were doing. This last thing is going to be like, oh yeah, that's cool. Give me a lot of that. So something like this. Let me give you some F and G and H. I like it. Let me just start off with an easy question, the one that we've already done before. Okay, so here's my 3 functions. Let me just separate them so you can see who's really what here. So let me ask you this question. How would you figure out what g of -1? How'd you figure that out? Take a minute and figure out what that output is. All right, so what are you writing over here? Yeah, so G tells you use this function. -1 tells you the input to the -1. I'm replacing x with -1. So I replace x, -1. 2 minus -1 over 3 times -1. I'm just plugging -1 in. Just want to remind you guys, that's the easy question I can ask, right? So kill that question. Just kill it. So on top you get 3. -4, so you get -3/4. Bam. I like it. But that question, I could ask you like F of 2 and H or whatever. So here's the more interesting question. So what is, let's see if I can make that. What do I, oh yeah. Ooh, all right. Let's just see what happens. What is, G of H of 4. Okay, let's work this out together. In fact, the thing you always do is the same thing you do here. When you're simplifying something, don't you start in the very inside and work out? Okay, so what am I putting into G? Whatever that shit H of, okay, well, that's where I start. If I only knew what H of 4 was, if I knew what that number was, it would be just as easy as this. Right? That's the right way to look at this. So you work the inside out first. So what is H of 4? Yeah, square root of twice 4 plus 1. That's what h of 4 is. That's the number that it represents. And let me just put that number in a better form, right? So what 2 times 4 is 8, plus 1 is 9, square root of 9 is 3. So I want g of 3. So see, it's really just one step away from that first. I just had a problem inside, and then I can work out what the actual question is. What's g of 3? Plug a 3 into g, 2 minus 3 over 3 times 3 minus 1 equals negative 1 over 8. Okay. All right, let me let that sink in. So you can imagine, if I felt really like being evil, I could do, what is f of g of h of...
What's the number in the parentheses? 2 minus 3 over 3 parentheses.
Oh, the number 3 and me have
Oh.
issues with each other. Okay. You guys feel okay with that? I mean, okay. So if I did ask you, what is g of h, g of f of h of, you guys start to see what I mean here?
Yeah.
G of f of h of, what, Jeff? I don't know, man. 12. Russian nesting doll, right? If you have multiple parentheses, you start on the inside parentheses, then you work your way out. It's exactly the same thing you do here, thank God. I got to know what the hell this is, so I know what I'm plugging into this. And I got to know what the hell this is, so I know what I'm plugging into this. So you start at the very innermost. So what is h of 12? It'll be twice 12 is plus 1, 25, square root of 25, 5. So now I know what I'm plugging into the damn f function, right? So what's f of 5? 19, and then I can, I don't know if I'm feeling good. We done f of g, haven't we? All right, or no? All right. Is everybody with me so far? So what number is that? I know. Now what number is this? I know. Now what number is this? And then I'll be done, thank God. So now you just plug a 2 minus 19 over, well, I have to make g this thing. Whatever the hell that shit is. Right, 56, I mean, negative 17 over 56, I think. Okay. Everybody's like, that sounds fine, Jeff. Move on. All right. Now. Let me do a couple more of these, and then we'll see. I think that's moved a little bit. What is it? 130 up here. Let's see if you guys can get this one here. What is f of negative 1? People freak out about this, but it's no different than this. It really isn't. F of negative 1 is a number. I got to figure out what that number is, so then I know what I'm plugging in. People are like, you're plugging f into itself. Well, not really. I'm plugging a number into f, right? So what is f of negative 1?
F of negative 5.
Yeah, it's negative 5. So now I know I'm plugging a negative 5 into f, and I get negative 20 minus 1. I get negative 21. So it's really the same idea. I just reuse the same function. It's called like iterated uses of the function. Repeated. Yeah. Okay. Oh yeah. And here's something. So that's one thing. That's just substitution multiple times is really all it is, right? The basic idea of function notation is easy. It's just substitution. Here you got to substitute and then substitute and then substitute. Okay, well, what do you math people seem to always make one problem have 18 parts. Fine, right? That's really all it is. Now watch this. What's your gut tell you to do with this? Yeah. So a slightly better way to write this is what this is really saying is add f and g at 1. So a better way to write this is f of 1 plus g of 1. Do you guys see that? So this notation is a little bit funky. But really, that's all it means. And that makes more sense in a way. Because I can figure out what f of 1 is, and I can figure out what g of 1 is. What is f of 1? 3. What's g of 1? No. 1/2, yeah. Right? 2 minus 1 over 3 minus 1, so 1/2, so 3.5. Woohoo! So what if I would have put a minus there? Then you would have subtracted. What if I would have put, what do you think you do with this? What does that mean? Multiplication. So you do 3 times 1/2, 3/2. What if I did this? I mean, I'm sorry, I don't mean to make you feel bad if you're not quite, but it tells you what to do. This is what that symbol means. When you first see these, you might be like, how do I add f and g? What the shit is that? But at 1. So you add what they are at 1. So that's a little bit better way to rewrite that. So then I can just attack it. Subtract what they are at 1. Where's the I didn't even write that. Multiply what they are at 1. Divide what they are at 1. So what's the thing to be careful about here is if g is, if the output is 0, then of course it would be undefined, but you just write that. So this would be 3 divided by 1/2, right? 3, yeah, is 6. So the last little piece of that section is just, can you plug stuff in and then add those things, or subtract those things, or multiply that? I hope the answer to that would be yes. It's just realizing what that notation means. And it means exactly what you'd hope it would be. Blah, 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 blah. Cool. Let me see if there's any little thing I left out. Oh, okay. Okay. Shoot. I didn't bring those with me. I think we're going to do a little bit of 8.5. Tomorrow, the very first thing we're going to do tomorrow is I'm going to bring my little calculator bag with me, in case you don't have a calculator yet. If you have a calculator, make sure to bring it tomorrow. We'll talk about some of the basic stuff of how to use the calculator. I'm not going to put a ton of, now I sound like I'm done, but I just said we're going to do a little bit of 8.5. I'm not going to put a ton of stuff that uses the graphing calculator on this first test yet. But I just want, there might be a couple of questions out of section 8.4 that ask you to use your calculator. All right, so tomorrow